Hi, I'm Kannan. Now we are going to see this project as multiple LEDs. All you need is an Arduino Uno board, and a resistance. This is 1.5 kilowatt, 1.5 kilo ohm resistance, and few LEDs. I've taken 4 LEDs. One is red LEDs and green LEDs. Okay, these are all jumper wires. It has a male to male connection, and you can just connect Arduino board and the breadboard together. And another board is this is a breadboard where you can use it without soldering, and you can use multiple prototype projects on this. And obviously you need a cable with this. Okay, now I'm connecting a resistors in this. Like, these all pins are connected into parallel, so if you connect in this one hole, it means it is connected all the way to this, same like this is a ground pins. This LED has two pins. One is positive and one is negative. The longer pin is positive. The shorter pin is negative. So what I'll do, I'll connect all the positive to the positive resistors and negative to the ground. Resistor, where it is negative to the ground. We're going to connect the pins as according to the boards that we have put in, like 8, and the other pin is 7, the other pin is 4, and the other pin is 2, and one ground we needed. This ground goes to the LED, and all the terminals will go to the each individual. Hi, we are going to write a program for the blink with the multiple LED, and we'll do a lot of combinations, like let's say the direction change and the timing change and the blink frequency changes. For that, as usual, we'll go and create a new project with an Arduino IDE, and the main setup, wide main setup is there, and wide loop setup is there. And now we'll remove we'll declare our pins first outside the wide setup. That is a universal declaration that we can do it by a code name constant, const. Const is nothing but a constant. The value of whatever that you are giving will never change. That means you are assigning a particular pin to a particular character. Like let's say I'm gonna take LED, because we're gonna use 4 LEDs, so I'm gonna name it as LED1, that is equal to 8. The pin number 8. We'll choose only digital pins, so I'm gonna choose 8, 7, 4 and 2. So we'll repeat the same coding. LED2, that is equal to 7. ONST LED3, that is equal to number 4. And other thing is const LED4, that would be number 2. So now we have to finish with a semicolon, or otherwise the program will not recognize the end of the line. Now we have declared our pin numbers to certain characters, and see, I forgot int. So int is for LED constant, so const plus int. And the other thing is, now we're gonna write void setup. Void setup is nothing but we're going to declare what is the pin is going to do, whether it is going to work as output or input, that we have to declare. So what we'll do, we will declare like the code name is pin mode, PIN MS capital, pin mode semicolon, and what we'll do is pin mode is LED1 comma, that is output. Same thing to the all the pins, like pin mode MOD LED2 comma output, all in capital letter. And the other thing is same thing for the all the 4 pins you have to do. LED3, LED4, now the last, and we'll declare that as an output. So pin mode void setup has been done, and second thing is what we can do as void loop. So what we'll do, we'll try to blink each LED sequentially, like let's say first LED will blink, and second will also blink, and 1 will off, and 2 will get blink, and 4 will blink, and 5 will blink. Let's do that first. So what we'll do for that, what you have to do, you have to turn on LED1. We are using a digital pin, so we'll just put off digital write, what we're gonna do, digital write as LED1 comma, that is high, and next is we'll give some delay that depends on how fast the blink is to be blinked. So we'll use a delay code for 500 milliseconds. All you have to do is write delay on 500 milliseconds. So second is that LED has turned on for 5 seconds, 5 milliseconds, and we'll turn off for another 5 milliseconds. So what the code is, same code we're going to write like digital, right? W is capital letter, and the for the same LED, right? LED 1 comma high LGH, and we'll put a delay again. So if you remember the previous video, we have used only this code. This is a basic loop code that we have used for only one LED. So what we'll do, we'll put as multiple LEDs. Let's say I have to do it for LED 2, LED 3 and LED 4. So for that you can just copy and paste it, and just change the name. That will be easy way to do, or you can, if you want, you can type uh, this is LED 2, and make sure everything is on within a loop. Control B. So now all we have to do is to change this name 3 and 4. So that's it. We have successfully completed 4 LED, and what we have done is we have blinked first LED and you have turned on and turned off. So you don't forget to change this high as low, otherwise every light will glow, you won't get a blink. So don't forget that. So change that into out, high or low, LOW. So we have successfully turned on first LED, and we waited for 5 microseconds, and we have turned off that same LED, and we have waited for another 5 microseconds, and we have done everything for all this 4 LED. We have done this. So that's it. We have completed a multiple LED blink program with a sequence input, like let's say from the sequence starts from LED 1 to LED 4. So what we'll do, we'll write this program to our microcontroller, and we'll see what is the result. Okay, we'll see the screen records. I'll go to that main record. Okay, now what we have done, we have seen the output of whatever the program that we have done this. So you can actually play around with let's say 500 microseconds to 1000 microseconds. So that will change the speed. We'll see what happens if we do 1000 microseconds. So what we have done is we have changed the timing. Now we'll see the output of that this particular this thing. Okay, now it is easy to change the direction of the LED, like I was telling you, from left to right to left. All you have to do is you have to change the pin numbers. Like, let's say that LED one is assigned to pin number 8, and LED 4 is assigned to pin number 2. So if you change the direction, if you want to change the direction, all you have to do is you have to change the pin configuration. Like, let's say I'll change into 2, this into 4, this into 7, and this into 8. That is all you need to do to change the reverse direction from left to right. If you upload this, then you can see the output. We'll see the output, how it changes from right to left to left to right. So we'll upload this and we'll see the output. So double blink, for the double blink, you have to turn on the LED first. Say, let's say LED 1, it is turned high, and wait for 500 milliseconds. And if you want to turn off for 500 milliseconds, all you have to do is you have to do this code again. So it will do the same sequence again. So, like, let's say Control C, Control, like same. If you do, you'll actually change the entire sequence. So now what we have written as a program as is to LED 1 to turn on, and wait for a 500 milliseconds, and turn off for a 500 milliseconds. Again, I'm turning on the LED button, LED 1, and the same sequence happens by LED 1, LED 2. So what is happening here is it will actually double blink. It will blink twice, and the same sequence will happen all from LED 1 to LED 2. So we'll see the output, and we'll upload this, and we'll see the output on that. Okay, now the program is uploaded, and you can see the double blink on this. So now what is happening, the LED 1 is turning on and off, and on and off, and the same sequence is happening for the double blink. So this is a few example where you can play around with LED, and we'll see the next program as next project as controlling the dimness of the LED with a potential meter. Thank you. We'll see you on next video.